Okay, so we are about to go over our Unit 8 practice test that deals with factoring trinomials and a few binomials. I hope you noticed when you were actually doing the test, there were no problems of just greatest common factor because that's included with the two at the bottom. Uh, so, again, I'm going over the practice test for those that probably haven't even started. Uh, this is how it's going to be graded tomorrow. And I have put in Schoology a old practice test. You get 3 attempts. It actually tells you the correct answers after each attempt. Again, it's just for practice. You could do it tonight. You could do one time tonight. You could do it tomorrow as you're doing your at-home test. Just whatever. Do want to thank my subscribers. And if you haven't subscribed, go ahead, subscribe, hit the like, hit the bell. Okay, so that's not where we're going. All right, this is. All right, first thing is it wouldn't be something from Mr. Jeffries if we didn't have a typo. Okay, originally this was a plus that would have made this prime. There's no way that you can actually get a negative in the a negative one in the middle, and from this now. Again, with all of these, you're going to start with 2 sets of parentheses. Okay, put your variable, put your variable. All right, now this highlighted negative that you should have changed will tell you that your signs are different. This right here will tell you that your bigger number's negative. Now, unfortunately for all my viewers and subscribers, we actually worked this one out on the whiteboard earlier and found out that this would be 2 and 3. Now, if you happen to write x minus 3 first and then x minus 2, that's fine. Just have the right signs with the right numbers. Okay? All right. Now, I'll try on the test I may change all the variables to x tomorrow because I can't even write a very good t. Okay. So, this tells us our signs are different. All right. This tells us what? Yeah, bigger number negative. All right. So, if you were listing, because remember I showed y'all this, you could actually list these factors. You know, some people are going to go 12 and 1. They're going to go 6 and 4. Or not 12 and 1, 12 and 2, 6 and 4, 8 and 3, and just make this negative. Hang on one second for. I'm sorry for all those having your extra conversations. I am doing math right here that you can see later. All right, so this would be a positive 4 and a negative 6. All right. Moving on. Okay. We put our ends in. What does this sign tell us? This plus in front of the 14. Yep, they're going to be the same. This tells us they're what? Yeah, both positive or both plus. Okay. Now, when you think of 14, what do you think of two numbers that you multiply to get to 14? No, not 1 and 4, but yeah, 7 and 2 or 2 and 7. Yeah, that's how you would write or type 14 is a 1 and a 4, but yeah, 7 and 2. All right. Then I'm going to kind of erase this a little bit, give us some room. All right. So, X and X. This plus in front of the 6 tells us our signs are the same. This tells us that they're both what? Both negative. Because a negative times a negative is a positive. When you add two negatives, you get a negative. All right. I wonder what numbers that you multiply to get 6 will add to get 7. Yeah, 6 and 1. Yeah. You would not believe how many times I get like 7, like positive set or -7, +1. I mean, I get some weird answers. Okay, which I totally understand their line of thinking, but no, yes, ma'am. Are you sure? Double check on your calculator. See the calculator on your desk? Yes, but we're looking for the factors of this. What two numbers we multiplied for this that add to get this? Okay, that would if, all right, your original question, -6 times -1. What is -6 times -1? Yeah, +6, what we have here. What is -6 plus -1? Multiplications on the far right, additions in the middle. The suspense is awful. I hope it lasts. Number 3, okay? Right. And -6 times -1 is +6. -6 plus -1 is -7. We'll put a pin in this and we'll work this out separately. All right. Number 5. This negative in front of the 28 tells us our signs are different. Okay. This positive in front of 3 tells us what? Okay. If they're different, how can they both be positive? Big number is positive. Okay. All right. When we think of 28, what are some numbers that 7 and 4, which one's bigger? 7. Bless you. Okay. Now, number 6. This negative in front of the 14 tells us our signs are this negative in front of the 5 tells us what? Big number negative. Okay. So, what are two numbers that we know multiply to 14? That's not 1 and 4. 7 and 2. Which one's bigger? That's right, because -7 plus 2 is -5. And then, okay. Now, believe it or not, you have a way to check to see if every single one of your answers are correct, other than the calculator. If you actually were to go back and multiply them like we had on the Unit 7 test, that's a way for you to do that. Now, it's just like the stuff from the Unit 1 test where it says solve the equation and check your answer. Nobody ever does that. Nobody ever does that. Okay. All right. Are we good with numbers 1 through 6? Besides the confusion on number 4 that I'll deal with later. Okay. All right. So, working on the number 7. P here, P here. All right. This negative in front of the 36 tells us what? Yeah, different signs. So plus and minus. Okay. Yeah, this tells us our big numbers. Yeah, big numbers positive. And somebody's already told me the answer that it would be 9 and 4. Now, if you weren't able to guess those right numbers right at the beginning, is there anything wrong with actually going through and listing the factors? No. Okay, because what's funny is the more that you actually list those factors for the students that need to do that, it actually helps you later on. Okay, so it's just practice. And I'm not going to force you to try to learn a way that doesn't work for you. Okay, now some of y'all have been like, well, I don't like math, and you've been doing that all semester, but potato, potato. All right, number 8 is a pirate's favorite problem. All right, this negative in front of 3 tells us what? Mm-hmm. This negative in front of the 2 tells us what? All right, this one's really hard. What are the only numbers that you can multiply to get 3? 3 and 1. Bam. I've actually had students stuck on a problem like this before. And like they could do all these harder problems and they get to this one, they're like, they couldn't figure it out. I was like, are you okay? They were just overthinking the problem. Okay. Now, 9 and 10. What do we know? What kind of problems are 9 and 10? The exponents. Yes, they do have exponents. You are absolutely correct on that, sir. Okay. Not going to lie. But these are dots, the difference of two squares. Okay. Now, this is some of the stuff we did Monday. Now, with the difference of two squares, we know that the signs are going to be different. Okay. Because that always different on the dots. All right. Now, what is the square root of 4? 2, and we put a D with it. What's the square root of 81? And that's it. Okay. All right. On 10, what's the square root of x squared? X. Why is it 3? Very good. The square root of 9 is 3. If you wrote 1x, guess what? That is absolutely okay. I will not give you a reverse mohawk if you put a 1 in front of the X. Okay? Some students need that stuff. All right. Are we good through 10 now? Yes. Okay. All right. Now, number 11. How many different ways do we have to do number 11? 2. Okay. Now, we have the first method, which is grouping. Okay. Now, remember, when you do the grouping, you have to grab that negative right there. All right. Now, if we look at this first grouping, what is the GCF between 10 and 35? Yeah, well, it will be a y squared. Yeah, but I understood what you were saying. That's not a big deal. Okay. Yeah, it's the lowest exponent. Now, we know we're going to divide out a negative because 6 is negative. What's the GCF of 3 and 21? I said 3, but it should have been 6. But oh well, potato, potato. Okay. Now, on on the left in red is factor by grouping. On the right, it's the box method. Now, either way, you're going to get the same answer. Okay? You have either method. And I know some people, they're like, man, I love that box method. And then some people are like, what the heck is up with the box? Okay? Now, what's really funny is that there are some people that did the box method or table method for multiplying, but yet you're not doing it for factoring. You have some people that did double distributive for multiplying, but they're doing this uh, for factoring. All right. Now, over here, some people that did the box method for multiplying are actually doing factor by grouping. Okay. Here's the thing, you got choices. Okay. Choices are good. Do you want to be a special guest on today's episode? No. All right. So yeah, I'm recording right now. So yeah. So I have a special guest from my Algebra 2 class. So they swung by to get a water and now they're on the YouTube. Okay. Peace out, Girl Scout. Okay. Okay. They were not wanting to do that. That was so funny. Okay. I said they were not wanting to do that. It was so funny. They're like, oh my gosh, he's recording right now. All right. It's kind of like that one time when Miss Smith brought in Trevor, and like I just told her to come on in. I'm like, we have a special guest, and I made her. It's like a show. It's kind of like Dr. Sheldon Cooper and Fun with Flags. Now, we did learn this yesterday. It doesn't matter how you put these terms in the box for those doing the box method, you're going to get the same answer. Okay. All right. Over here with factor by grouping, what's the GCF between 12 and 18? 6. Okay, I've already got the W squared. Somebody's throwing that out there. Thank you very much. Okay, so I get 6W squared. And this would end up being 2 dubs minus 3. Now, if you're ever having a hard time, especially if you're doing factor by grouping, which is on the left, if you think about it, you've got your GCF is whatever is going to make this be right here. So what are you going to have to divide 10 by to get 2? Yeah, 5. So it can actually help you. Okay. And again, either method is fine. Bless you. All right. Now, some of y'all might have thought, wow, this was a really short test. There's only 12 problems. And there's no back. But believe it or not, I did not change this very much from what I used to do years ago in Algebra for Mastery. We would still have 12 problems. Okay. If now, here's the deal. We are not getting away from this concept. We will actually revisit this concept later in the semester. Okay. Um, this is one of those things, and I talked to a couple of different people. Everybody, I hear a lot of teachers say factoring is so important. Well, it is if you're one of those that's going on to like calculus and higher level math and stuff. If you're one of these people that, because you have to use it to solve some formulas and stuff later on and derive things, but you know, as far as like a everyday engineer, rocket scientist type people, they probably don't do it. Okay. And I guarantee you, my stepdaughter that is a hairstylist does not use factoring in her day to day job. Yeah. Your uncle that is an actual rocket scientist doesn't use factoring. Okay. He probably had to have that foundation to get to something else, but as far as it every day, no. So I think this is where I disagree with some things and a lot of people don't like. Percentages and fractions, which is a 7th grade math standard. Basic algebra. I love it. Absolutely love it. All right. So that's the review of our practice tests. So good stuff, good things. Roll Tide.